Hello again, welcome back to the shop. This is Randy. Today we're going to be working on the hit and miss motor again. Last video you saw me machining the flywheel, and both the flywheels are done. Off camera I worked on the governor weight. I got that done. The only thing I can say about that is the drawing is rather vague on the weight, and I made spring to the dimension on the drawing with the correct wire. It calls for a 16 thousandths wire, and it was just way too soft. It wasn't going to work. So I spent an afternoon figuring out what I was going to do there. I made the spring to dimension with the size wire 3 times, and all 3 times the result was the same. The weight would just hang on its own. The spring wasn't actually pulling the weight back. So I made a spring a little smaller in diameter with a little thicker wire. I used a 20 thousandths wire on a 150 thousandths mandrel instead of a 1/4 inch mandrel like the drawing says, and it seems to work. I won't know on that until after I actually get the engine running to see how the governor acts. But I'll grab the camera here and I'll swing you around and show you how this works. Here's the governor weight right here, and it's got a little piece in it that pushes against this collar. You can see the collar moving. And when I turn the engine over, get in the right spot here, when the governor weight comes up, it locks it in that detent right there, and when you turn the motor over, it locks and allows the engine to free spin, and then when it comes back around, it unlocks and frees up your push rod so that your exhaust valve is working again. But the dimension, the description, what they told you had to do to this weight was really vague. Just kind of went by the picture more than anything. So both the flywheels are done. The governor weight is done, like I said. Today we're going to be starting on the fuel mixer, and I've got the fuel mixer chucked up in the 4-jaw, trued up just the best possible, and I have to do some preliminary machining on it before I actually excuse me, actually start the actual machining of the mixer itself. So let's head on over to the lathe and have a look. Okay, I got this trued up in the 4-jaw best as possible. The first thing I have to do is machine this down here. The spigot needs to be machined to 375, and then I got to flip it around and do some machining on the other side of it. So and then this part here, after it's done, gets machined off. Okay, first thing I'm going to do is true up the end and then turn the OD. it's cleaned up enough so I can get a measurement on it here and see. Almost. Uh, 456. Put that in the DRO. Needs to be turned to 375. I wasn't quite sure if it needed a radius or just comes up to the shoulder. It has to be machined up to the shoulder right here, right to here. So I'm going to do that now. Okay, now this can come out of the 4-jaw. I'm going to put the 3-jaw chuck back in, and I'll be back. Change the plans. I put the collet chuck in instead, and I'm going to face the end, and I'm going to rough turn this down till it's smooth, and then I have to cut this part off because this is going to be made into another piece. If I put the lathe in gear, there we go. Yeah, we looking here. Yeah, that almost cleaned up all the way. Okay. Now I got to take this out. I'm going to saw this part off, and we'll start machining on the fuel mixer itself. All right, I got this sawed off and faced off. Now I got to turn a step in here, 94 thousandths deep to 750 diameter. So I'm going to come in 94 thousandths. Right there. I'll make a mark. Now this has got to have a hole drilled in it, a 1/4 inch deep, 7/16 to get tapped for half 20. Had to move the camera again. Okay, first thing I'm going to do is put a center in it. Okay. And I think what I'm going to do is I'm going to drill and ream the hole for the flow valve all the way through. All right, now I'm going to drill this. I'm going to drill it for half 20 tap drill right here, and I got to go 344 deep. Okay, I'm going to start this tap here, and then I'm going to finish it by hand. Okay. All right. Here we go. I don't know if you'll be able to see this or not, but at the bottom of this thread here, I had to cut a relief. So I use this little tool that I ground up and cut a 94 thousandths thread relief at the bottom here. Now I got to cut the valve seat. All right, I got the seat, cut it down in the center there using this tiny little boring bar. And I had the compound set at 45 degrees, so I cut the seat. The little tip of the boring bar is right here. So now I'm going to work on making the valve that goes in there. The valve needs to be 438 in diameter and 375 long total. It's 678 thousandths in diameter right now. I gotta turn the OD down to 438. Speed that up a little bit. This is 304 stainless too. Checker size here. A little warm. .478, 478 and a half. I gotta go to 438. Size should be right on. We're at 440. Or 438 and a half. That'll be good. All right, we're at 199. I got to turn it down to 187. Check it here, see where we're at. We're at 188. Okay. Check this here. We're at 186.9, so that'll be good. Now the actual stem has got to be turned to 94 thousandths. Come up here to my stop. And I got to back up 134. check our size here. Should have 10 to go. Well, no, not quite. We're at 99, should be. Looks like we're 3 thou up on size. We're sitting at 103, 102 and a half. So I'm going to take 7 thousandths. We're at 96. I don't think it cut anything. Check it and see. No. 96 still. I'm just going to file this a little bit. Really close. About a half thou big on this end. Right there, 94. Okay. All right, now we're going to cut our valve seat, our valve face rather. All right, now the valve gets a little knob turned on the top of it. And that little knob has got to be an 1/8 inch in diameter. I'm just going in with a parting tool here till I reach that diameter. Turn it down to 125. You good right there? That little knob on the top needs to be 62 thousandths tall. Now we're going to part it off. There it is. I got to turn this little stub off the top of there and take out the hole for the center. Well, there's the completed fuel control valve right there. I ended up just filing this end off. And same thing over here, I filed that little nub off. This one's a little different than my other one. When this valve opens, the air inlet actually flows around the valve into the cylinder head. That's why they had you narrow this down so small. I was wondering why they did that, but that's why that's why. Well, I think this is going to do it for this video. Got some progress done on the fuel mixer, and have the intake valve completed. The only thing I have to do is drill a tiny little hole in it for a little pin that's going to hold the spring on the bottom of it. And I got to make a little bushing here that the stem is going to fit in, that will get soft soldered in place when the rest of the machine work on this part is done. So more progress on the Galloway hit and miss engine. So hope you enjoyed that, and we'll see you in the next one. Take care. Bye-bye.